Hello and welcome to Quadratics 2.2, graphing from factored form. Okay, so it's gonna be a big lesson, so it's gonna be kind of a long video. So sorry about how long the video is, but there's a lot of stuff to do. So yeah, try to pay as much attention as you can, and yeah, just rerun the videos as many times as you need to kind of understand what's going on. Okay, so in the first problem, it's basically gonna, I guess, teach you about certain locations or parts of a parabola or quadratic graph that you need to know, because when we eventually start graphing this from scratch, then these are the dots you're going to want to have on your paper when you eventually start drawing out your curve. Yeah, because this is not like the straight line graphs that you guys did for lines, where all you got to do is have pretty much like two dots. Yeah, parabola graphs you need at least three. Yeah, I mean I mean you can get by with three, I guess, but you probably want a little bit more than that. Yeah, maybe four at the very least. Yeah, but you don't want to have just two. You cannot draw a parabola function or a quadratic function with just two dots. Yeah, because this is not a line. So get to know the name of these dots. So P and Q on both graphs, they're known as the x-intercept because that's where they hit the x-axis. The R's on both graphs, they're known as the y-intercept because that's where they hit the y-axis. Okay. All right. So let's go on to the next slide. And I have the same exact labels for the dots again. All right, and I have on the side here P and Q, which you know are the x-intercepts, R is the y-intercept, right? But the thing that you might not have realized is when you actually write the coordinates for those dots, yeah, the coordinates, because it's the x-intercept, they're going to have zeros in the y-coordinate spot. And the y-intercept is going to have a zero in the x-coordinate spot. And this is going to be like this forever. Yeah, so whenever somebody tells you to write the coordinate of an x-intercept, you're going to automatically write 0 for the y value. And if anybody ever tells you to write the y-intercept for the coordinates for the y-intercept, you're automatically going to write a 0 for the x value. Okay, and this is going to be how it is forever. Yeah, there's never going to be a situation where you're talking about the x-intercept and you don't have a 0 in that y-coordinate position. That's impossible. That's not going to happen. Okay, and just like the y-intercept. Yeah, you're never going to have a situation where when you write the coordinate for the y-intercept, you're going to have a 0 for that x value. All right, so that's why we can lock these numbers in stone pretty much. We can lock them in stone, and we can just pretty much rely on the fact that they're going to have zeros in those spots. Okay, so that's these first couple of slides wanted to get you guys to understand. Yeah, that when you start to eventually find the dots that belong to these graphs, they're going to correspond to coordinates that have zeros in those spots. Okay. All right, so some patterns that they want you guys to recognize. Yeah, so let's see, the x coordinate, I believe, is underneath that box. Yep, the x-coordinate of the y-intercept is always 0, and the y-coordinate of the x-intercept is always 0. Okay, so it's just putting into word form what I just showed you visually in the previous slide. Okay. All right, so it says in problem 3, find the coordinates of the x and the y-intercept. So I put a question on this slide. Why are these coordinates already pre-written this way? Yeah, and I just talked about it, right? That I told you, if it's the x-intercept that we're dealing with, x-intercepts have y equals 0. I mean, the y value is 0 rather. Okay, and if we're talking about the y-intercept, the x value is going to be 0. That's no matter what. All right, so when we have to find the x-intercept, here's one thing that's going to connect with the previous lesson that we actually just came from. So you know how you guys might have been bummed out that you didn't get to practice your zero product property from the previous lesson. Well, we get to practice it right now. Yeah, we get to solve for our x's. So let's write down the problem that corresponds to this equation. So it's gonna be 2 times the quantity x minus 1 times the quantity x plus 3. Okay, and by use of zero product property, just like in the previous lesson, we're gonna find what is called our x-intercepts. So we're gonna set each of these x's equal to 0. Okay, and when I do that, we're gonna get left side x minus 1 equals 0. On the right side, we're gonna get x plus 3 equals 0. So when I solve for each of these x's individually, I add 1, and I get x equals 1 for my first value of x. So what's so cool about this is we actually just found our first x-intercept coordinate, and it's going to be a 1, 0. That's going to be my coordinate of my first x-intercept. So by doing zero product property, yeah, the technique I taught you guys in the previous lesson, we're going to use that technique to find the location of x-intercepts when given the equation for the quadratic function. Okay, so let's solve for the other x-intercept. Okay, so x plus 3 equals 0, so subtract 3 on both sides, and I get x equals negative 3. So that's going to be my second x-intercept location. Okay, and here's how you can actually read coordinates, because I don't really think I taught you guys how to read coordinates as far as what they mean. Yeah, so basically your x value, I talked about that being your input in a previous lesson way back when. Yeah, so x's are your inputs, y's are your outputs, or your answers. Yeah, so in this particular situation, here's how you can relate it to the problem that we're on. Yes, if I look at 1 comma 0, and I look at the parentheses x minus 1, 1 is going to be my value that when I plug it in, produces an answer, produces an output of 0. So plug 1 in, get 0 as an answer. Plug negative 3 in, get 0 as an answer. Okay, so that's how this works, right? The x value is what you're going to plug in. The y value is going to be the answer to that number you just plugged in. Yeah, and this is handy because, like I said, we're able to use this technique pretty much to get our x-intercept location. Okay, all right. Is it going to be that easy for the y-intercept? Yes and no. It's not going to be as easy as this, but it's going to be not that bad because having a 0 for our x value means we get to plug in basically the easiest number in the world to plug in, right? Why is 0 the easiest number to plug in? Well, because is it going to really change anything by putting a 0 when you plug it in? I mean, yeah, when you multiply by 0, it's going to make everything 0, so that's actually pretty easy. But when I plug in a 0 to adding and subtracting problem, it's not going to really make a difference. Yeah, so let's just do that. Let's just plug in 0. So we got 2 on the outside of the parentheses, we got 0 minus 1, and we got 0 plus 3. So we basically have 2 times negative 1 times 3. Yeah, so let's see. I have a single negative in my entire multiplication problem, so I know my guaranteed answer is negative. Then I basically have 2 times 1 times 6. Right? Because I know my answer is negative, so I don't have to worry about the negative one anymore. I'm just basically looking at 2 times 1 times 3, which is 6. Okay, so my y-intercept is 0 comma negative 6, and we're done. Okay, so this is the technique I'm going to have you guys do for pretty much the rest of the problems. Yeah, maybe not all of them, but the majority of the problems you're going to actually be using these techniques to get the x-intercept and the y-intercept location. So you're going to get good at this technique, hopefully by the end of this lesson. Okay? Alright, let's look at the next problem. Okay, so I'm not going to spend too much time on this lesson or in this slide. Yeah, it's just pretty much giving you information about stuff that we kind of talked about. Yeah, and yeah, I'm not gonna spend more time on this slide. You guys can just fill in the blanks with what's written on the video. Just push pause. Yes, you can write it down. All right, so number 5. Okay, so now they want you to figure out a different location, a different value, yeah, or a different location on this graph. And then it's not really shown on this picture on the right-hand side, so I'm actually going to draw it in, and it's going to be right here, the vertex. So the vertex is right there. There's my vertex. It's either going to be the highest point on your graph or the lowest point in your graph. And I think I talked about that in a previous lesson also. Yeah, that vertex is going to be in either one of 2 locations, the highest or the lowest point on the entire graph. And in this case, this is a parabola that's opening up. Yeah, so it's going to be a minimum vertex. So actually, let's call this a minimum vertex. Minimum. Let's get into that habit of labeling what category of a vertex it is. It's a minimum vertex. We don't know how low it got, but we know it's a minimum because it's at the bottom of the graph. Okay, and I kind of broke up the vertex as far as getting the coordinates into this little, I guess, pattern, where to get the x value, you're going to add the x-intercepts together and divide by 2. Okay, and that's going to pretty much give you what is called like an average or the midpoint. Yeah, so that's how you're going to get the x value of the vertex. Then you're going to get that x value, you're going to plug it into your equation, and you're going to get the corresponding y value. Okay, so let's get my x-intercepts of this problem first. So sometimes kids, when you eventually start just looking at the equation, here's what you can do. Here's how you can manipulate things, yeah, to make this to go by a little bit faster. You just take the problem that's already written in your paper. You just write equals 0 next to the x's. Yeah, and right underneath, I guess, wherever I can figure out some space, you can just write x equals 1. So sometimes you're going to just start doing this stuff in your head, and x equals negative 3. And that's basically going to give you your coordinates for your x-intercepts. So when you start doing this process enough times, yeah, you're gonna just be able to do it exactly like how I just showed you guys just now. You're not gonna have to write down all those steps where you actually do add 1 both sides, subtract 3 both sides. Yeah, all this stuff is gonna eventually just be done in your head. And because you're in my class and you don't get to use a calculator, doing work in your head is going to get a little bit easier, because by not using the calculator, your brain is going to get a little bit stronger and it's going to be able to do calculations internally a little bit easier. Yeah, so it might not be easy right now because maybe you guys use a calculator a lot in your previous math classes and your teachers let you guys get away with it, but not in my class, okay? Because I want you guys to get your brains stronger, all right? So this is one of the uses of having a stronger brain, right? Where if there's some calculations that need to be done in your head, it can be just done right on the side right here, yeah, without having to write everything down. Okay, so we're going to grab our two x-intercepts, which are x equals 1 and x equals -3, and we're going to add them together just like this says. So we're going to, let's see, let me write down what we're going after. Vertex x coordinate. Okay, and to do that, we're going to add our x-intercepts. So we're going to go 1 plus -3 divided by 2. Okay, and 1 plus -3, hopefully you guys know how to do this. Don't use a calculator to do this calculation, right? It's going to be -2 divided by 2, and that's going to eventually be -1. So my x value of my vertex is -1. Okay, so basically what I just did was I added up my x-intercepts and I divided by 2, and that's how I got my x coordinate of my vertex. Okay. To get the y-coordinate of the vertex, we're going to grab that x value that we just figured out, which is -1, and we're going to plug it into the equation. So now we're going to do the work for the vertex y-coordinate. Alright, so we're going to plug in -1. So it's going to be 2 times the quantity -1 minus 1 times -1 plus 3. Okay, so it's basically 2 times -2 times 2. Yeah, so let's see. We have a single negative in my entire multiplication string, so it's going to be a negative guarantee. And 2 times 2 times 2 is 8. So we get -8. And there's my vertex. Okay, so on the side here, I can actually write minimum vertex at y equals -8. So you don't have to actually write this for the problem, but I'm just going to show it to you anyway, because in the future we're going to have to actually write this down for a lot of our problems. So the more times you see it happening and where I'm getting these numbers, like where did this -8 come from? When I put minimum vertex at y equals -8, where did that -8 come from? Well, it comes from the y value of the vertex. Okay, and how do I know this thing is a minimum? Well, because it's at the bottom of the graph, right? So if the vertex is at the bottom of the graph, we call it minimum. If the vertex is at the top of the graph, at the highest point, we call it a maximum. Okay, so I'm just going to show it to you here because, like I said, with repetition, you guys will start to recognize it when you see it, and it's going to get easier to do on your own. So I know it's not mandatory for this problem, but I'm just going to show it to you anyway. Okay, number 6. So notice how we're doing x and y intercepts. So I already have the zeros all pre-written in. Okay, they're all pre-written in. So I'm going to look at my equation real fast, and I'm going to just start figuring out my x-intercepts, right? Some kids, you're not even going to have to write down these equal zeros above the x's. You're just going to just make all that happen in your head. If you need to write down the equal zeros on the paper, that's fine. And eventually your brain is going to just start computing it real fast. Yeah, so you're going to get first parentheses is 1, x equals 1. Second one is 5. So you're going to put a 1 and a 5 in each of these parentheses. And then this is where some kids ask this question. Does it matter which number I put in which parentheses? Can I put 5, 0 and 1, 0? Does the order matter? No, the order doesn't matter. Yeah, some teachers are going to want you guys to write the dots from left to right, but I'm not going to be that picky. Yeah, so just take your cue from your teacher, and if they want it that way, then do it that way. Yeah, I don't need to have it that way, so don't worry about it. You can put the 5, 0 in the front, the 1, 0 in the back. It doesn't matter to me. All right. Okay, so y-intercepts, we're going to plug in 0. So let's do that over here. So let's actually write y-intercept. So you know that this work belongs to y-intercept, and we're going to plug in 0. So we have negative on the outside, then we have 0 minus 1, and then we have 0 minus 5. So negative, and then -1, and then -5. So we have 3 negatives. So this is an odd amount of negatives. So the first 2 negatives can cancel out with each other and make positive, positive. The third negative doesn't have any other negative to cancel out with and make positive, positive. So my overall answer is going to be negative. And then I'm just going to go, okay, so that's my signs. Now I just have numbers. So 1 times 5 is 5. So -5 is my y-intercept. Okay. And then I'm going to do vertex. So remember now, vertex is going to be done in 2 parts, right? Because I want to get the x coordinate and then I want to get the y coordinate. And you have to go in that order. Okay, and I'll explain very shortly why it has to be x coordinate first. It's going to make sense after a while, yeah, but it might not be totally clear right now since you only saw one problem done with vertex being figured out. Okay, so we're going to go after the x coordinate of the vertex, and if you remember from the previous slide, that involves grabbing your x-intercepts, adding them together, and cutting them in half. So my x-intercepts are 1 and 5, so add them up and cut them in half. So 1 and 5 makes 6. Cut it in half, we get 3. So there's my x coordinate of my vertex. And the reason why I had to get that first is because how do I get the y value if I don't know what number to plug in? Because you got to remember now, the x value is what you plug in to get your y value, the answer. So without plugging something in, you cannot get the output. Yeah. So if you're at a job and your boss says, okay, how much are you going to get paid this week? How many hours did you work? And you're like, oh, I don't know, I forgot. Do you think you're going to get paid the correct amount? Yeah, you might if you guess correctly how much hours you think you work, but you're probably not going to guess correctly. Yeah, so without knowing the input value, there's no way you can get the correct output value, and that's why the x value has to be figured out first. Okay, so we got 3 for our x value, so we're going to figure out vertex, the y value, and we're going to plug in 3. So we got negative on the outside. Oops, write a negative. Okay, so 3 minus 1, because that's the number we're going to plug in, right? We're going to plug 3 in place of x. And then we got 3 minus 5. So negative times 2 times -2. So how many negatives do we count altogether in the entire problem? Right? Because an even amount of negatives make a positive answer. Odd amount of negatives make a negative answer. So that's why the previous problem had 3 negatives, so it was odd. Or not previous problem, but the y-intercept rather. Okay, in this one we have 2 negative signs in our problem, so we get a positive final answer. And then 2 times 2 is 4. So my vertex is 3, 4. Okay, so I'm just going to do this anyway. You don't have to do this for your problems that look like this. I mean, there's other problems that you actually have to graph, and you're going to have to do this. But for this particular problem, this is not a graphing problem, so I'm not going to require it. But I'm just going to show it to you so that you can see this more times, because repetition will make it become more familiar. So this is a vertex, right? Because it's either at the highest or the lowest spot on the parabola graph. So it's at the highest point in this particular situation, so we're going to call it a max or maximum. You can write max or maximum, doesn't matter to me. And you're going to tell me how high it actually got. How high did it reach? So it was a maximum at y equals, and what was my y value of my vertex? 4. Okay, so how high that vertex went is based on the y value of your vertex. So since it was at a height of 4, your max value is 4. Okay. All right. Next problem. Okay, so next problem we're gonna start comparing one parabola to another. But the hard part is when we compare them to see who has the smaller minimum value. One guy is written as the equation, yeah, the function, and the other one is actually written as the graph drawn out. So how do we compare who's the smaller minimum when one guy is a graph and one guy is an equation? Right? Kind of hard to make that comparison, right? So we're going to have to find a particular piece of each of these functions that we can compare to each other. And since we're comparing the minimum value, right? Who is in possession of what is called the minimum value, right? Does the x-intercept have anything to do with the minimum value in the sense of I grab a number from the x-intercept and I use it to say that this is the minimum value? No, yeah. And this is why I showed you guys on the previous 2 problems where I did that extra step where I said max value at so-and-so, minimum value at y equals so-and-so. Because I wanted to show you guys that connection where the max and the minimum value come from the vertex. So if I want to compare who has a smaller minimum value, I have to compare one vertex to the other. Okay, getting this vertex for the graph is actually pretty easy because all I got to do is look at the graph. So if I look at a graph, the vertex is right there. That's the lowest point right there. So what is the coordinate of that dot? So this is my vertex, minimum vertex, and his coordinate is at 1, -1. Yeah, so he is called n, so n of x vertex is 1, -1. Okay, so there's basically, when you guys do these problems on quizzes and tests, there's basically 4 things I want to see in your paper. Yeah, the first 2 things are the location of the vertex values, the vertex coordinates of each of these quadratics. So you got one vertex already, 1, -1. Okay, so let's get the other vertex. So to get m's vertex, right, because that's what we want to go after next, m's vertex, we're going to grab his x-intercepts, we're going to add them together and cut them in half. So let's see, what are his x-intercepts? So m of x, the x-intercepts, and eventually you can just look at the problem, you can just look at x minus 2. So what number do you think you can plug in place of 2 so that it cancels out -2? If I put a 1 in place of x, will 1 minus 2 become 0? No, that's going to become -1. So what number can I put in place of the x that when I interact with -2, so I put number minus 2, what's the only number I can put in place of x that's going to cancel that out and make 0 overall? And hopefully you say 2 is my number that does that. So if I plug in a 2, 2 minus 2 is 0. And what's the number that's going to cancel out -4 and make that a 0? Hopefully you say 4, right? Because if I plug in 4, 4 minus 4 is 0. So those are my 2 x-intercept locations. So to get my vertex, I'm going to add my x-intercepts. So I'm going to go 2 plus 4 and cut it in half, which makes 6 over 2, which makes 3. So there's my first half of my vertex, 3, comma, and then now the y value. Okay, and now you got to get the y value by plugging in the number we just got. So we're going to plug in a 3 to get the corresponding y value, and we're going to plug it into my equation. So it's going to be 2 times 3 minus 2 times 3 minus 4. Okay, so it's going to be 2 times 1 times -1. So overall answer is negative because I only see a single negative in the entire problem. And 2 times 1 times 1 is 2. So my vertex is at 3, -2. Okay, so these are 2 to 4 things that I want to see on your paper. The vertex location for n, the vertex location for m. Okay, the third thing I want to see on your paper is who is winning this contest, right? Because it basically says who has a smaller minimum value. So who's winning? Who's going to win this contest? Who's going to win this battle of the smaller minimum value? So that's where you got to compare the y value of each of these vertex locations. So you're going to compare -1 versus -2. And you're going to ask this question: who has a smaller number? Right? Is -2 smaller or is -1 smaller? And hopefully you remember this. Right? When you compare negative numbers, right, you want to ask yourself, who is farther away from 0? Is -2 farther away from 0 on a number line, or is -1 farther away from 0 on a number line? Because whoever is farther away is the smaller number. And hopefully you say -2 is a smaller number. So therefore he has a smaller minimum value. Okay, so you're going to respond with this. You're going to say m of x has the smaller minimum value. So that's the third thing I want. You want to state your winner. Who's your winner? So m of x is the winner. He has a smaller minimum value. And then now your fourth thing that I want is y. So you're going to say because, oops, don't forget the c, U-S-E, okay? And you want to make an inequality statement proving how you evaluated and compared the 2 numbers. So you're going to just say -2 because -2 is less than -1. And that's your proof. That tells me how you know m is the winner because -2 is smaller than -1. Okay, so the 4 things I want are the 2 coordinates, the 2, I guess, functions in this problem, m and n. right? I want to know who the winner is, and I want the proof, the inequality statement. So that's the 4 things I want to see in your paper whenever you do a problem like 7a. Okay, I'm going to do 7b right now as well because I want you guys to see this problem again. Yeah, and you have 3 to practice on your own for homework. So let's do this. All right, so we're going to compare M versus G. So G is right here, he's the graph, and his vertex is right there. So his coordinate is, what does that look like? 1, 4. Okay, so G of X vertex is 1, 4. Yeah, so that's the first thing I want, right? I want to know the vertex location of one of the 2 things. Then I want to know the other vertex location, so that's going to be M. And this is the one we got to work for, right? Because it's given to us as an equation. It's not given to us as a graph, so we can just look for the dot. It's given to us as an equation, so we got to actually figure it out by doing calculations. So to figure out the x-intercepts of M, we just look at the parentheses. We see x minus 3, and we see x plus 1. And to get the x-intercept values, we just ask x minus 3 a simple question. So we go x minus 3. Yeah? What cancels out your negative 3? What number can I put in place of x so that when I go, that number minus 3 becomes 0? And hopefully you respond with 3. So 3 minus 3 makes 0, right? Plug in 3, you get 0. Then you say the exact same question to x plus 1. What cancels out x plus 1? Yeah? What number, if I put it in place of x, you go, that number plus 1 equals 0. And you're going to hopefully respond with negative 1. So negative 1, when you plug it in, makes my 0. Okay? So to get my x value or x coordinate of my vertex, right? So x coordinate, we're going to go 3 plus negative 1 divided by 2. And 3 plus negative 1 is 2, divided by 2 is 1. So you got the x value of the vertex. Okay, and that's super important because without the x value, I cannot plug in anything to get the y value. So getting that 1 is super important. Okay, so now we're going to plug the 1 into my original equation. So negative 2 times 1 minus 3 times 1 plus 1. So that's negative 2 times negative 2 times 2. So when I figure out what sign my final answer is going to be, the negative negative, that's 2 negative signs, so that makes a positive resulting answer. And 2 times 2 times 2 is 8. Okay, so there's the first 2 things that I wanted whenever you do these problems. I want the 2 locations of my 2 vertex values in my problem. Okay, so vertex G, 1, 4. Vertex M, yeah, 1, 8. Okay, and to do the third thing, you're going to tell me who wins. It says who has the smaller maximum value. So which one of these 2 numbers is a smaller number? Is 4 smaller or is 8 smaller? And hopefully you say 4 is smaller. So who owns that vertex value that has 4? And hopefully you say G owns that vertex that has 4. So when you announce the winner, you're going to say G of X has the, what is it, smaller maximum. You can just write max if you want. Value. So that's the third thing I want, the winner, right? You announce the winner. And then now you write your because, your inequality statement. So you're going to say, why is he the winner? Because 4 is less than 8. And there you go, all done. Okay, so C, D, and E, I'm not going to do, I'm going to leave that for your homework assignment. Okay, and then this next slide is going to be the steps that you're going to do for graphing. Yeah, so I'm gonna not spend too much time on this slide because I'm actually going to show you guys how to graph it. Yeah, I'm going to take some time to actually run it through with you guys. So I'm just going to skip to that problem right now. Okay, so we're going to graph this equation. And when you graph it, you're going to be like, oh wow, the steps that I do for graphing are kind of like the steps I just did on a lot of other problems just now already anyway. Where if I got to write out the x-intercept, I'm going to start doing this already, right? Parentheses, comma 0, parentheses, comma 0, right? Because I know that the 0 is in the y value for my x-intercepts. And then for my y-intercept, I'm going to just going to start writing out 0, comma blank, right? And for vertex, I'm just going to write blank parentheses. I don't know any of them, but I know it's going to be at least looking like that as far as the form is concerned. Okay, so when I look at my equation, I got x plus 2 and x plus 4 as my parentheses. So what cancels out a positive 2? Yeah, what number can I put in place of x so that when it combines with positive 2, it makes 0? And hopefully you say negative 2 does that. And if you did, good job. Okay. And then what number is going to cancel out positive 4? And hopefully you say negative 4. Yeah, so we just got our two x-intercepts. That was pretty fast, right? Okay. All right, and in the x-intercept, that's just going to involve plugging in the easiest number in the entire world, right? What is the easiest number in the entire world to plug in? 0. Yeah, so we're going to plug in 0, so we're going to get 0 plus 2 and 0 plus 4. So we basically have 2 times 4, which is 8. So our y-intercept is 0, 8. Okay, and this is the y-intercept. So actually I should label this work, yeah, so that you guys know that this work helped me create y-intercept. Okay, and now we're going to go vertex, x value, x coordinate. Okay, and that's going to involve grabbing our x-intercepts, adding them together and cutting it in half, dividing by 2. So negative 2 plus negative 4 divided by 2. So negative 2 plus negative 4 is negative 6, divided by 2 is negative 3. Okay, so I know my x value of my vertex is negative 3. Okay, the reason why we have to go for that one first is because to get the y value, we need to know what to plug in. We cannot get the y value if we don't know what we're plugging in. Okay, so now we know it's a negative 3 that we're going to plug in, so we're going to plug in that number into our equation. So we're going to go negative 3, oops, let's write this down, vertex, y coordinate. This is the work for that. Okay, so negative 3 plus 2 and negative 3 plus 4. Okay, so we got negative 1 times 1, which is basically negative 1. So there's my vertex. Okay, so let's plot these dots. Yeah, and if I start plotting these dots, then I can start drawing my graph. So negative 2 comma 0, that's a dot that's right there. And negative 4 comma 0, that's right here. Wow, these two dots are super close together. Yeah. And then 0 comma 8, so that's right about there, I believe. And then negative 3, negative 1. Okay, so in the steps that was on that previous slide, the one that says these are the steps to graph a parabola, it actually lists 4 steps. Yeah, if you're in my class, I'm not gonna require you guys to do the 4th step, which is find additional points so that you can use more points to get the feel and shape and pattern of where this graph is going as far as where it's headed. Yeah, because the right side looks pretty much good to go. You have the vertex and you got 2 dots on the right. Yeah, left side is not so mapped out as well because you got the vertex and you only got 1 other dot. Yeah, so I think the other teachers in this school, they're kind of on the stricter side and they actually make you guys do additional points. But for me, since I make you guys, for my kids, there's things that I make my kids do that are kind of irritating. So it's like a give and take, right? Sometimes I make you guys do more, sometimes I cut you some slack. So in this particular case, you don't have to do additional points. You can just connect the dots and draw the parabola connect the dots based on how you know the parabola looks, which is curved. Yeah? Do not connect these dots with a ruler. That is not how you do a parabola graph. Do not connect with a ruler. If I see you start connecting the dots with a ruler and having these things all straight, then I will make you guys do additional points. Okay? So when you draw your graph and you connect all your dots, yeah, it's not pretty, it's not beautiful. My parabola, when I connect the dots, are really ugly. It's super hard to draw it nice. Yeah, but I am gonna ask for certain characteristics being shown on the graph. Like you see how I went all the way to the edge of the grid? If you don't go all the way to the edge of the grid and you stop at the dots, I'm gonna stop giving you points. And when you draw your parabola all the way to the end, make sure you put arrows. If you don't put arrows, yeah, if you stop putting arrows, then I'm going to stop giving you points. Okay, and I need you guys to label every single one of these dots. So this dot right here is the y-intercept. These 2 dots right here, that's x-intercept. This dot right there, x-intercept. And this dot right here, that's your vertex, and I want you to categorize him. This is a minimum vertex at y equals negative 1. Okay, so this is the part where I said, right, yeah, I don't force you guys to do additional points, but I make you do other stuff. Okay, and this is an example of me making you do stuff that's not really always, I guess, pertaining to what a graph is, right? When you draw the graph, right, you don't expect to have to write minimum vertex at y equals -1. Yeah, but I'm going to make you do that. Yeah, and if you don't do that, I'm going to subtract points. All right, because this kind of habit of getting into this kind of doing some extra stuff is going to help you guys out when we actually get to other lessons. Yeah, so that when you see it again, you can be like, oh, okay, I did this like 100 times already, so it's no big deal. When I have to do it officially for other problems. So, yeah. Okay. All right, so let's go on to our next problem. I think the next problem is our last one. Yeah, it is. This is the last problem. So it's going to be a graph again. Okay. So you're going to see the exact same steps. So eventually you're going to get real good at doing the x-intercepts. You're going to say what cancels out +5 in that first parentheses, and you're going to say -5. What cancels out -4 in that second parentheses, and you're going to say 4. Ooh, I don't like the looks of this problem. Yeah, my vertex value for my x value of my vertex is going to be kind of ugly. It's going to be a fraction. Okay, my y-intercept, I know it's going to be a 0, 0 comma something, so let's plug in 0. So we're going to figure out the y-intercept, and we're going to plug in 0. So what does that say? 1/4. So 1/4, and 0 plus 5, and 0 minus 4. Okay, so 1/4 times 5 times -4. So that's going to overall be negative. And 1 times 5 times 4 is 20 on the top. 4 times 1 times 1, because those are all my bottom numbers, is a 4. So basically I got -5. So that's my y-intercept, 0, -5. Okay. So vertex x coordinate. We're going to add our x-intercepts. So we're going to go -5 plus 4, and you're going to cut it in half. So you basically have -1 divided by 2, which is -1/2. So my x value of my vertex is -1/2. Okay, and here's where the fun part starts. Now you get to plug in -1/2. And if you're in my class, guess what tool you don't get to use? You don't get to use a calculator for this next step. You're going to do all of this by hand. So I know it's going to get kind of irritating, but that's how it is. Yeah, you can't get your brain stronger by having a tool do the work for you, right? So we're going to plug in -1/2 into our equations. So we got 1/4. So actually, let's write down what we're going after. Vertex, y coordinate. Okay, so 1/4. And then we got -1/2 plus 5, and -1/2 minus 4. Okay, so -1/2 plus 5 is 4.5, and -1/2 minus 4 is -4.5. Okay, so when I multiply this out, I'm pretty sure I don't want to leave this as a mixed number, so I want to make everything into improper fractions so that when I go top times top times top, and then bottom times bottom times bottom, I know who's where, right? And if it's a mixed number, I can't tell who's on top and bottom. So 1/4 times 9/2, right? So change the mixed number into an improper fraction, times the 4 and the 2 to make 8, add the 1 to make 9. So that's how I get my 9 on the top. And then I got -9/2. Okay, so overall I know my final answer is negative, because right, positive times negative is a negative answer. And when I figure out the top of the fraction, so 1 times 9 times 9, that's 81. And 4 times 2 times 2, that's 16. Okay, so I can't leave -81/16 in as an improper fraction, because I gotta plot this dot, yeah. So this is going to be known as negative, and 16 goes into 81, I believe, 5 times, with 1 left over, so 5 and 1/16. So my y value is -5 and 1/16. Okay, and you're probably thinking at this time, whoa, this is like kind of crazy. I got to do all that fraction stuff in my head. I can't use a calculator. That's kind of nuts. No, it's not. Okay, to do higher level math. Yeah, and to actually have the stamina to get through bigger problems that you're going to get in the harder classes that you're going to experience. Yeah, your brain cannot get tired that fast. Yeah, you cannot get tired by saying, "Oh wow, I just used all my brain cells trying to get -5 and 1/16." Yeah, if your brain gets tired just from doing that, then you're not going to have the stamina to survive calculus and all those other kind of classes. Okay. All right. So let's start plotting our dots. So -5, 0, that's an x-intercept. 4, 0, and 0, -5, that's my y-intercept. And -1/2 and -5 and 1/16. So I know that dot is going to be probably right around there. Okay, so this is where I'm not going to get strict. I'm not going to say, sorry, you didn't put it at -1/2, -5 and 1/16. You put it at -1/2, -5 and 3/16. No, I'm not going to do that. Okay, my eyes are not that good where I can see where we actually put that vertex dot. Okay, so just get it in the right box, right? Notice how this is the box that the dot should be in, right? So -1/2, -5 and 1/16. That's kind of like the right location. Okay. And I won't be picky as far as, oh no, you didn't put the dot in the exact right spot for a fraction. Okay, so connect your dots. And like I said, when I connect my dots, my graphs are ugly. I don't connect them very nicely. So I'm not grading on how pretty the graph looks when you connect all these curved lines. Just make sure the characteristics are there. So you make the graph go all the way to the edge, right? You go all the way to the edge of your grid. You put the arrows, and you start labeling your dots. So x-intercept, x-intercept, y-intercept, and this is a minimum vertex at y equals -5 and 1/16. Okay? All right, we survived. 41-minute video. So good luck on this assignment. Yeah, I know you're probably going to have questions. So yeah, I will see you in class and go for it. Ask away. Okay? Bye-bye.